Factors and greatest common factors. Factors are integers that are multiplied together to produce a product. 2 and 3 are factors of 6 because 2 times 3 equals 6. A whole number can have many factors. What are all of the factors of 6? Well, 1 times 6 is 6, so therefore 1 and 6 are factors of 6. 2 times 3 is 6, so 2 and 3 are factors of 6. -1 and -6 are also factors of 6, and -2 and -3 are factors of 6. Therefore, plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6 are the integer factors of 6. What are the positive factors of 12? Well, 3 times 4 equals 12, so 3 and 4 are positive factors of 12. 2 times 6 and 1 times 12. Therefore, 1, 2, 3, 4, 6, and 12 are the positive factors of 12. Determine the positive factors of the whole number. For 18, we go through which numbers can multiply together to equal 18. Well, 1 and 18, 2 and 9, and 3 and 6. So those are the positive factors of 18. For 42, we have 1 times 42, 2 times 21, 3 times 14, or 6 times 7. So those are the positive factors of 42. 2 or more integers can share factors. These are called common factors. When referring to common factors, only positive factors are considered. So what are the common factors of 12 and 18? Here are the factors of 12. Here are the factors of 18. So we have gone ahead and circled the common factors, the factors that appear in both lists. 1, 2, 3, and 6 are the common factors of 12 and 18. The greatest common factor, or GCF, is aptly named. It is the largest of the common factors. In this example, 6 is the greatest common factor. All right, let's find the common factors of 10 and 15. So, 1. 1 is a factor of both. Let's see, 2 is a factor of 10, but it's not a factor of 15. 3 is a factor of 15, but not 10. 4 is not a factor of either. 5 is a factor of both. 6 isn't either. 7 isn't either. 8 isn't either. 9 isn't either. 10 is a factor of 10, but not 15. All right. Factors of 10 cannot be greater than 10. So therefore, the only common factors are 1 and 5. Therefore, the greatest common factor must be 5. Monomial factors are monomial expressions that are multiplied together to produce another monomial. So 3x and 6x squared are monomial factors of 18x cubed, because if you multiply them together, you get 18x cubed. What are the monomial factors of 18x cubed? Well, we have some integer factors, including 1, 2, 3, 6, 9, and 18, because those are the factors of the coefficient 18. And for x cubed, we have 1, x, x squared, and x cubed. Those are the 4 factors of x cubed. So what is the total number of monomial factors of 18x cubed? To get all of the factors of 18x cubed requires pairing each of the integer factors of 18 with each of the factors of x cubed. In this example, there would be a total of 6 times 4, or 24 monomial factors. Rather than making a long list of the monomial factors of 18x cubed, the information can be captured in a simpler way. The monomial factors are shown as 2 sets, one for the integer factors and the second for the monomial factors. This notation implies that a red number in the first set is paired with a green expression in the second. 2 or more monomials can share factors. These are called common monomial factors. When referring to common monomial factors, only positive coefficients are considered. So what are the common factors of 3x and 6x squared? So the factors of 3x are 1, 3, 2x and 3x. And the factors of 6x squared are all of these. We have 1, 2, 3, 6, x, 2x, 3x, 6x, x squared, 2x squared, 3x squared, and 6x squared. So we circle the factors in common. Therefore, 1, 3x, and 3x are the common factors of 3x and 6x squared. Find the common factors and identify the greatest common factor of x squared and x cubed, and r squared, r cubed, and r to the 5th power. Alright, so for x squared we have 1x and x squared. For x cubed we have 1x, x squared, and x cubed. So in circles we see the common factors here, here, and here. Therefore this is the largest one, x squared. For r squared we have 1r and r squared. For r cubed we have 1r, r squared, and r cubed. For r to the 5th we have more. We have 1r, r squared, r cubed, r to the 4th, and r to the 5th. We circle the greatest, we circle all the factors, and we see the largest one is r squared. Identify the greatest common factor between x cubed y squared and x squared y cubed, and 20x squared y squared z to the 5th, and 15x to the 4th y to the 4th z to the 4th. Okay, so when we have x cubed y squared, to find the factors, it's going to be all the factors of x cubed, which is shown here, multiplied by, or it could be matched with, any of the factors of y squared, which are shown here. So we do that for those two. Then we have all the factors of x squared and all the factors of y cubed here. All right. Then we look through and we see, okay, x squared is the greatest common factor for x cubed and x squared. And y squared is the greatest common factor between the y terms. So therefore, x squared times y squared is going to be the greatest common factor. We do the same thing down here. So we have 20 in the front, which means we need all of the factors of 20. We have x squared, so we need the factors of x squared. We have y squared, so here are the factors of y squared. And we have z to the 5th, and here are all of the factors of z to the 5th. We do that same thing for 15, x to the 4th, y to the 4th, and z to the 4th. Then we go through and we find the largest value, so the largest number or the largest exponent in all of those sets, and we multiply those together. So then we get 5x squared y squared z to the 4th.